Sorry, excuse me. So thank you very much for attending this symposium. So this is the first event of our brand new project, Contrarian Biology. It has just started this April in support of one of Kaken categories, 学術変革領域B. I'm Hironori Shi from Kansai Medical University. Let me introduce the outline of our project instead of project leader Miyamoto-san. He will give a talk later. So the project has four research teams handling flies, medaka, monkeys, and humans. And 9 researchers are joining this project from different fields of biology, like behavioral neuroscience, physiology, psychology, comparative cognition, genetics, and evolutionary dynamics. So it's a kind of collaboration of neuroscientists and ecologists. And what we're gonna do is studying contrarians. Well, actually, I need to start by explaining what contrarian means. So also this English word is not major, at least for Japanese people. This word in Japanese has now come to be very popular in recent days, especially for young people and on the internet. That is 逆張り. So it means opposing or rejecting popular opinion. A similar word is twisted. So just impression, but twisted is more based on one's personality, while contrarians do it more intentionally or strategically. Anyway, we have always seen such a person in our classroom, workplace, and anywhere, or we could be the one. Contrarian exists also in animal societies. So even in well-organized collective behavior of fish, you can find one who behaves differently from others. It may not due to genetic variability because we found such individual in the homogeneous colony in the laboratory, which will be shown by Takashi-san and Yokoi-san in the later talks. Well, actually, you might already seen it in your experiment, as in they make outlier in your result, then the P goes about 0.05. So the question is, why they exist in the society? And we hypothesize contrarian might get some benefit by doing that as minority advantage. So they are not just simply noise or just losing or neglecting others. This is a meaningful or intended action. In addition, social system also might need such asynchronous individuals. So they may help society. So they are not just bad boy disturbing the harmony of society. Let me walk you through the hypothesis. The study in the field of neuroscience have found running system of animal to find reward associated things among similar but irrelevant stuff, and also study the value conversion system to pick up better reward between ones having the different identities, sizes, risks, and costs. So those support optimal decision making of individuals. Of course, a good reward for you is also for others. So recent study also have focused on how animals manage this conflict throughout competition, cooperation, and altruistic behavior as social interaction between 2 or 3 individuals. However, actually, there are many more individuals in the society. And in principle, the power of inter-individual interaction become weaker in the larger group. For instance, in monkeys who have a very strict social hierarchy, the lower rank monkey steals food when the higher rank monkey looks away. So the monkey needs to pay more effort to maintain his or her domination in the group. So in other words, making a group rises competition cost. then this may enhance some individual withdraw from this conflict and voluntarily choose suboptimal option. Actually, so to be honest, this is what humans do when we become contrarians, but it might be a good reason for animal as well. And humans and monkey are very good at considering what others are targeting. And so theory of mind, metacognition would be tightly linked this kind of job, but some of you may concern, oh wait, oh, flies and fish can't do it. That's true. But let me play with this toy simulation by using an algorithm called Boyd. So Boyd algorithm can mimic corrective behavior like birds, but with very simple rules. So 3 principal rules are given to agent. The number 1, cohesion, so approach others when finding, and then number 2, separation, so move away when getting too close to avoid collision. And number 3, align the movement direction with others. So here, the agents are initially dispersed in the field like this, and let's see how it works. So they start gathering and then making groups, and finally become a one group. It looks really like some real life, right? Then here I add one more attractor to the agent, which is food. So 10 high value and 10 low value food are spread in the 2 patches. And then 20 agents start foraging from the bottom. So let's see. So all agents flock to the high value bite, and then color of agent will change to magenta when they get food. After eating all high value food, they move to the lower value food. Some of them who are unlucky or started from the bad position did not get any food, so lost this race. It's not surprising. Then I introduce one agent as a contrarian. I changed this 3rd rule in this agent to flip the direction of shorter axis of alignment vector. So which means when others go to the right, this contrarian go to the left. It's quite stereotype of contrarian. See, so this orange one is contrarian. Let's see. Yes, contrarian go to the left when others go to the right. And then there is one more important point here. After foraging, the contrarian stays in the group. Let's see as a trial. Yep. Yes. The agent goes to the left again, and then go back to a group. Okay. So when the direction of head of agent are diverse like this, the group moves straight way, and then contrarian counts in the group. However, the heads are aligned, the contrarian no longer stay and must leave. So this toy simulation shows that the simple contrarian-like behavior can be generated by such a simple trick. By the way, you may also want to see what happened if all agents were contrarians. That might be interesting. Let's see. Actually, they can make groups, but it's very inflexible. So they are very poor at foraging, as you see. So they move only in a straight way, like this, because they always restrain each other. So contrarian should be minority in the society. Right. So this toy simulation partially shows that the simple contrarian-like behavior do not always require advanced cognitive ability like the primates have. So contrarians could exist in a wide variety of animal societies. So let me go back to our hypothesis. So for individual, contrarian behavior might be not the best strategy, but provide moderate benefit with the lower cost of competition. For society, contrarians may reduce social tension from resource competition. Moreover, contrarian would scoop vacant niches and expand group productivity. Foraging is just an example situation. Contrarians have to be in any situations like mating, predation avoidance, migration, and settlements. So contrarian may universally work in various societies and situations which suffer from overconcentration. Contrarians may be built into a social system to solve this kind of overconcentration. So this might be one answer to the question of how animals have developed the society beyond the unavoidable downside of making groups, so that is competition cost. However, of course, for now, this is just an idea. So there are our steps of our project. So number one, we have to establish a behavioral paradigm to assess contrarians if they really intentionally do it. So majority, minority dependent, and then they get some benefit by doing that. And number two, we have to conduct the experiment for a long time or using a simulation to assess the long-term gains for both contrarians and society. And then after that, we can study the neural and genetic basis of some contrarian behavior. So as I said, contrarian here does not mean one specific behavior. So we will study different contrarian behavior in different animal and situation and a different neural and genetic basis. However, we think there should be one common principle of contrarian phenomena. So that is what we want to find in this project. So in the next talk, we will show you the experiment detail of each research team. All right, so Takashi-san, please start next talk.